any kind of compounds with the same molecular formula and it will be different with physical and chemical properties will be called as isomers. That organic reaction is nothing but a breaking of bond or making of a bond. Two types of stereoisomerism are there, that is stereoisomerism and optical isomerism. A free radical is nothing but a neutral species with an odd number of electrons. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up the session 4 from the chapter Organic Chemistry, that is some basic principles and techniques. In the last class, we have discussed about the rules for naming branched alkanes, naming of cyclic compounds, naming of organic compounds containing functional groups. Overall, the nomenclature of the organic compounds we have seen in the last session. So, in this session, we will discuss about the isomerism and fundamental concepts in organic reaction mechanism. The kinds of isomerism, what is isomerism and the kinds of isomerism with their examples, and the fundamental concepts of organic reaction. To write an organic reaction or to proceed with the organic reaction, what are the fundamental concepts we have to learn? Those things you will study in this session. So first we will understand what is isomerism. Okay. The compounds with the same molecular formula with the different structural, the compounds with the same molecular formula but different physical and chemical properties are called as isomers, but the phenomenon will be called as isomerism. Okay, once again, any kind of compounds with the same molecular formula and it will be different with physical and chemical properties will be called as isomers. The overall phenomenon will be called as isomerism. Okay. This isomerism will be divided into structural isomerism and stereoisomerism. Okay. What is structural isomerism? That structural isomerism is the compounds with having same molecular formula but its structure will be different. The structural formula will be different. That kind of compounds will be called as isomers. That isomers, that overall phenomenon will be called as structural isomerism. And it is further divided into chain isomerism, position isomerism, functional isomerism, metamerism. Okay. Here stereoisomerism. In this isomerism you will study about the each molecular structure, means the orientation of the molecule will be seen. From one atom will be above the plane, one atom will be below the plane. Those kinds of isomers will be seen here. It is also further divided into geometrical isomerism and optical isomerism. Okay. This is about the isomerism. Now, we will see the types of isomerism with the examples. Now, we will see structural isomerism. Compounds having same molecular formula but different structural formula are known as structural isomers. And the phenomenon is known as structural isomerism. Any kind of compounds with having same molecular formula but different structural formula will be there. That kind of isomers will be called as structural isomers. Okay. And the phenomena will be called as structural isomerism. And structural isomerism is further classified as chain isomerism. Compounds with same molecular formula but different carbon skeleton, different in the carbon skeleton are called chain isomers. Okay. What is that? These compounds also having same molecular formula but in the different in the carbon skeleton. What is the different in the carbon skeleton? How we can understand means, see here, C4H10 same molecular formula for the two kinds of structure. This is how they have written CH3, CH2, CH2, CH3. This is a normal butane, right? See here, CH3, CH, CH3, CH3. This is isobutane, like that they have written. Means all the 4 carbons are there, all the 10 hydrogens also there. But the structure is little bit different. This is straight chain, this is little bit branched. So that's what they are telling. Same molecular formula with different carbon skeleton is present. Next is position isomerism. This is also compounds with same molecular formula but different in position of multiple bond or functional group or substituent are called position isomers. Okay, it is the compounds are having same molecular formula but differ in the position of multiple bonds or functional group or substituent. Okay, see here C4H8, here also 4 carbon, here also 4 carbon, here also 8 hydrogen, here also 8 hydrogen. But what is different? The position of double bond. Here at the second position is present, but here at the first position is present. But same molecular formula is there. For that kind of isomers, we will call it as position isomers. Okay. Next is functional isomerism. Here also compounds with same molecular formula but having different functional groups are called as functional isomers, and the phenomenon will be called as functional isomerism. See here, the molecular formula is same C2H6O, but with the same molecular formula it will have a different functional group. How means? See C2H6, right? Here 3, 2, 1. What is this OH? Alcohol group. See here, this is methoxy, alkoxy group, right? That is why with the same molecular formula, the functional groups will be different. This is ethanol, this is methoxy methane. Here also C3H6O, see here CH4 aldehyde group, this is ketone group, right? That's why this is propanol will form, here propanone will form. Here also same molecular formula, the functional groups are same. That's why the compound will give a different property. Next is metamerism. Compounds with same molecular formula but different alkyl groups on either side of the functional group are called metamers, and the phenomenon is called metamerism. What is that? The compounds are having same molecular formula but the different alkyl groups on either side of the functional group. If this is a functional group, the either side of alkyl group will be different. See C5H12O, 1, 2, 3, 4, 5. Okay, ethoxy, propane will be called. Here see, methoxy, butane will be called. Right. Here after first carbon, the alkoxy group is present. Here after second carbon, alkoxy group is present. That's why the name will be changed. For 1 carbon meth, for 2 carbon eth. Right. That is how the names will be changed. Here 2 ethoxy propane at the second position is present. Here 2 methoxy 2 methyl propane. This is also changed. Okay. This is second set. And that is how these structural isomers have been defined and distinguished from one to another with its types. And now we will see stereoisomerism. Compounds having same molecular formula and sequence of covalent bonds but differ in relative position of atoms or groups in space are called stereoisomers. This phenomenon is called stereoisomerism. Means whatever the relative position of atoms in the space are present, it will be different and the same molecular formula will be present. And there are two types of stereoisomerism are there, that is stereoisomerism and optical isomerism. But as per your syllabus, about the stereoisomerism you will study completely in the next year. Here only you are studying its definition and the names of its types. That is more than enough for your syllabus for class 11 or first PUC. Okay. Next, we are seeing the fundamental concepts in organic reaction mechanism. For doing a reaction mechanism or proceeding a reaction, you should know what is substrate or what is reactant, what is product and what is the intermediates you will find out in the each kind of reaction. To understand, this is a general reaction. A general representation of an organic reaction is, this is organic molecule, reagent. Here it will form an intermediate, product will be formed. Intermediate might be a byproduct or it may not form also. Okay. Then what is substrate? Organic molecule which undergoes a chemical change. This is called a substrate. It is an organic molecule, right, which undergoes a chemical change. What is reagent? Any species which brings about the chemical change in the substrate. This is substrate, right? In this organic molecule or substrate, this reagent will bring the change within an organic molecule. Okay. And what is intermediate? Unstable species formed when a substrate is attacked by the reagent. When the reagent is attacked the organic molecule, it may form an intermediate which is unstable. It is not a long lasting time. It may lead to product also, but sometimes it will be present as a byproduct also. Okay. So, this is overall a general reaction, organic molecule, reagent, it will give a intermediate and product. This is called overall reactant, we will call. From the reactant, it will proceed to product. A sequential accounts of each step describing details of electron movement, energetics during bond cleavage and bond formation and the rates of transformation of reactants into products is referred to as the reaction mechanism. In the reaction mechanism, a little bit of step by step changes will be seen. What kind of changes or what kind of details will be seen? Electron movement, from one electron to another electron movement will be changed. Energetics during bond cleavage and bond formation and the rates of transformation. Here in the chemistry term, rate means nothing but time. Okay. Rates of transformation of reactants into the products is referred. Overall, the energetics, what kind of energies we are used and what kind of chemicals, how much time it required to form reactant into product, overall electron to electron movement, every detail of a molecule from an electron you will study under reaction mechanism. The knowledge of reaction mechanism helps in understanding the reactivity of organic compounds in their synthesis. What is the use of overall reaction mechanism means? Each kind of organic molecule will be understood by its reactivity and its synthesis will be done thoroughly by understanding the overall reactions. And fission of a covalent bond explains how organic reactions takes place. Fission means breaking of covalent bond will be explained how the organic reactions will takes place. Now, we will study deeply, that is fission of a covalent bond. Organic reactions involve fission of a covalent bonds. Okay. Fission means breaking, I have told already that organic reaction is nothing but a breaking of bond or making of a bond. For making it, there is a breaking should be happen, that is called fission of covalent bond. The fission, that see here, cleavage or breaking. Fission of a covalent bond can take place in two ways depending upon the nature of the substrate, attacking reagent and reaction conditions. Based on substrate, attacking reagent and reaction condition. Based on that, fission will be done by two ways, that is homolytic cleavage and heterolytic cleavage. Okay, first we will see what is homolytic cleavage. During homolytic cleavage of a covalent bond, each atom or group attached to that bond gets one electron of the shared pair. See here, it is overall one molecule. If it is fission of a covalent bond has been takes place means each of the molecule will get a one electron pair. See here, this electron, this molecule will get one electron, this molecule will get one electron. That overall molecule will called as free radicals. What are free radicals? A free radical is nothing but a neutral species with an odd number of electrons. Okay, it will be not in an even number. With an odd number of electrons will be present attached to the atom How it will be obtained? It will be obtained by homolytic cleavage. There might a question, what are free radicals? Free radicals are a product of homolytic cleavage which are a neutral species with an odd number of electrons will be seen. That is about the homolytic fission or cleavage. The atoms or groups obtained by homolytic cleavage are known as fragments also. Usually homolytic cleavage takes place in the presence of UV radiation or in the presence of organic peroxides. Usually homolytic cleavage when it will be happen when there is a presence of UV radiation and or organic peroxide is present. See here, this is Cl2, right? When Cl2 undergoes the homolytic cleavage in the presence of UV or organic peroxide is present, 2Cl will be given. 2Cl means Cl plus Cl, right? Two free radicals will be, the two free radical of chlorine will be seen here. Okay, the homolytic cleavage is performed in a non-polar covalent bond. There is no polarity will be there in the covalent bond. In that kind of substance only the homolytic cleavage will be seen. And stability of various free radicals. This is tertiary, one carbon attached to three other alkyl groups. That is tertiary, this is secondary, and primary, this is methyl free radical. Which is greater? Tertiary is greater than secondary, secondary is greater than primary, primary is greater than methyl free radical. The stability of various free radicals depends on the bond dissociation energy. Okay. Bond dissociation energy means the breaking up of, for the breaking up of covalent bond, there should be some energy. That energy will called as bond dissociation energy. The stability of free radical will be inversely proportional to the bond dissociation energy. It is how one and another will be related. That is inversely proportional. Okay. Next is heterolytic cleavage. During heterolytic cleavage of a covalent bond, both the electrons of a shared pair are taken away by the more electronegative atom or group. Means whatever the cleavage, by the cleavage of covalent bond, two electrons will be seen, right? Those two electrons will be taken by more electronegative atom or group. See here, A and B is a molecule, in between the covalent bond is present. If that is broken or breakage has been done means, this is more electronegative. Think like it is more electronegative, B is more electronegative. Due to that more electronegative nature seen in B, that both two electrons will be taken away from A. That time it will become cation, it will become anion. Okay. Heterolytic cleavage is preferred in polar covalent bond. For heterolytic cleavage of a covalent bond, there should be a considerable difference in the electronegative of the atom. Okay. One of the atoms should be more electronegative to abstract the electrons which will be obtained by the breakage of the covalent bond. If there is no more difference will be there is no chance of getting heterolytic cleavage. See here, this is methyl bromide. Bromine is more electronegative atom, we know that. That's why after breaking up of the methyl bromide, the bromine molecule has taken out the two electrons and here the carbocation will be formed. From the heterolytic cleavage, carbocation and the carboanion formation will be seen. See the stability of, this is methyl carbocation, this is ethyl, this is propyl. All are primary, secondary, tertiary and methyl carbocation will be in the increasing order. Okay. The carbocation are always sp2 hybridized and have trigonal planar shape. Okay. See here, carbanion formation, CH3CH3. Okay. That is nothing but ethane. Here the formation will be, see, this is more electronegative and here H plus has been taken out. What is the formation? The carbanion is formed. That is what I am telling. From the heterolytic cleavage, carbanion and carbocation will be formed. From the homolytic cleavage, free radicals will be formed. Next, nucleophiles. Any species which can donate one or more electrons is a nucleophile. Nucleophiles are electron-rich species. Due to it is electron-rich species, it can donate one or more electrons. They are either negative ions or neutral molecules with at least one lone pair of electrons will be present. At least one lone pair of electrons will be present. It may negative also, it may neutral molecule also. Negatively charged means Cl minus, Br minus, I minus, that is chlorine, bromine, iodine, nitro, amino, that is alkyl are negatively charged nucleophiles. This is neutral nucleophiles. See here ammonia, water, this is alcohol. Here at least one pair is there of lone pair, here two pair, here two pair. That is what they are telling. All nucleophiles are Lewis bases. Nucleophile is generally represented by Nu minus or these two electrons, lone pair of electrons. Next is electrophiles. Any species which can accept one or more electrons is an electrophiles. Electrophiles are electron deficient species and they either positive ions or molecules with incomplete octet. What are electrophiles? Electrophiles are deficient, electron deficient species. It may accept one or more electrons also. Usually it will be positive ions or incomplete octet state will be there. See here protium, that is H plus, this is H3O plus, this is NO2 plus, R plus, NH4, ammonium, you know a best example. Positively charged electrophiles, this is BF3 and AlCl3, aluminium chloride, sulfur trioxide, ferric chloride, these are all neutral electrophiles. All electrophiles are Lewis acids. Usually acids will accept the electrons, bases will donate the electrons. Electrophile is generally represented by as E plus. Next, electron movement in organic reactions. How the electron movement will be seen in the organic reaction? There is a three possible ways, that's all. The movement of electrons in organic reactions is shown by curved arrow notation. Curved arrow starts from the where an electron pair is shifted and it ends at a location to which the pair electron may move. The representation of shifting of electron pair shown below. See, if this double bond, there are two electrons will be present in single bond. This bond is shifted to the another side means we have to start from here to here. How it will be formed? This bond is shifting to here from pi bond to adjacent bond position. Double bond means one pi bond will be shifting to another adjacent. Here this bond or these electrons are shifting to the element means the lone pair of electrons, because those are electron rich. It will be formed as lone pair from pi bond to adjacent atom. If that from pi bond, from that lone pair to it is forming a bond means here it will shift for the adjacent bond. From atom to adjacent bond position. Okay, it may form bond to another side bond. It may move to bond to as a lone pair. It may form lone pair to a new bond. These are the three possible ways of electron movement in organic reaction. Next, the movement of single electron is indicated by half-edged curved arrow known as fish hook arrow. Okay, what you have to understand? Usually two electrons will be reached, two electrons will be moved, means one pair of electron. By the two electrons, the new bond will be formed. If there is a chance of one electron is moving from one side to another side, that time one headed like this will be formed. Like this, it will be moved. Here methyl free radical, here chlorine free radical will be seen. That is dissociation of chloromethane. This is about the electron movement and the isomerism, the various kinds of isomerism with its example we have seen in this class. In the next class, electron displacement effects in covalent bonds and types of organic reactions will be discussed. Students, I thought you have completely understood today whatever we have discussed. So, we will meet in the next session. Thank you.